in TUOS. So our topic will be Lean Six Sigma White Belt certification using TUOS. Well, pretty much what will happen in the next couple of minutes is that I'll walk you through what is Lean Six Sigma, what is this Lean Six Sigma all about, and then we'll end up with a use case wherein we will be showing you, or I'll be showing you how to navigate through very quickly, not too in depth, on how to navigate through the structure that is being used in Lean Six Sigma using TUOS. TUOS is the first Filipino cloud-based data analytics platform that we launched last December. So after this, we will be communicating with you on how you can get your free certification or the free white belt certification that you can use to buff your profiles. Right? See, so I think we are good to go. Let's start with, of course, that's me. I've been introduced already. Let's start with this question. If you're here, if you're an engineer or you're an analyst or whatever your background may be, this will be very helpful for you. But before we can go to the value that it could bring to you, let me ask you this question. What do you think distinguishes problem solvers from the rest of the other people in the space? All right. Analytical thinking, that could be one, of course. What else? Mm-hmm. If I will be asked the same question, okay, if I will be asked the same question, this will be my answer. Problem solvers like you and me, we use a structured approach, correct? We use a structured approach to solve problems. Okay, we put that step by step process so that we could be led to like the result that we're trying to create or deliver. Okay, now our topic for tonight is Lean Six Sigma, which is a structured approach. There's a step by step process to it, so you'll not get lost. Okay, for as long as you follow the approach. Now let's talk more about what is really Lean Six Sigma. Lean Six Sigma, as I've mentioned earlier, this comes from two different body of knowledge. So it was way back 1940s when Taichi Ono, a principal engineer from Toyota, introduced the concept of lean. So lean talks about eliminating the waste. So just imagine your processes. Just imagine the things that you're doing. Most of the parts of the things that you're doing in a corporate setup, or maybe at school when you do like some things at school, they, let's say if you have like 10 steps, not all of them really contributes to creating that value. Okay, so the lean methodology, it aims to remove those non-value adding process steps. Okay, now Six Sigma came into the picture. It was 1980s. It was introduced um by Dr. Michael G. Hardy and some other technical engineers in the team, and it was introduced way back in Motorola. The objective is to reduce variation. So why do we need to reduce variation? Variation, it's the source of why we have like errors or defects or mistakes in our processes. So unlike lean, we cannot completely eliminate variation unless otherwise you remove that process step or that entire process that is creating that error. Since variation, it's an inherent characteristic of a process, so it's always gonna be there, and you know all we can do is to really limit it to a certain degree that will not affect how customers perceive the quality of our products and services. So that's pretty much what Lean Six Sigma is. Lean is practical. Six Sigma, I would say, is statistical. There are the advantages and disadvantages. So like decades ago, practitioners combined this stuff. Okay, okay, and what happened is that the marriage gave birth to Lean Six Sigma, a way on how we can do improvements, how the way that the a way or structured way how we can improve things, solve problems, optimize processes, and all that. So that's pretty much the quick history about Lean Six Sigma. Okay. Now, what are the actual things that Lean Six Sigma can be applied for? So, this could be applied to processes that has like waste or non-value adding process steps, and that has like variation. Okay. Now, if we go to the usual setup that we're every one of us are, are experiencing right now, let's just take our experience in ordering online, right? Especially when the pandemic hit us. So there are like scenarios, unfavorable scenarios that could happen. So, for example, uh, the order that we received does not match our expectations. Like say for example, we ordered a an item that's supposedly is color yellow, but it turned out to be red, something like that. The item has defects or problems. Like you're expecting like a very good item, but when it has been delivered to you, there are like so many dents and scratches and all that. The delivery was done late versus the promised date, and when you try to call their customer service, it's too poor. Okay, and these are all scenarios wherein Lean Six Sigma can be applicable. This is in the service industry, but Lean Six Sigma is heavy on the manufacturing. If you're from the manufacturing, this regardless of whatever your engineering background may be, or even from your in your the business, most of the companies will ask you to be trained in the basic tools and concepts of Lean Six Sigma because it's really something that they're using, and especially in services, there are a lot of applications in the service. So but if you would go back, they are from the manufacturing, Toyota and Motorola, and then it was spanned into the services, right? Now, how does Lean Six Sigma thinking works? I always I love to discuss this particular equation here. This is a very basic mathematical equation. We call it the transfer function. It is read as y as a function of x. So what is y? Y is your response. Y is your output. Okay, so your output is definitely a function of the inputs. So you could be this inputs could range from 3, 5, 10, or more than 10 items or output. So that's the first thing. So whenever a problem arises at your y, what happens? You try to determine what are the causes of the problem, or what particular factor that have caused that particular problem. I call it, or we call it rather, the deterministic reasoning. Okay? So you try to determine what are the causes of the problem. So that's pretty much how it works. Now, from all the things that you've tried to list, okay, list down, so you have like 10 causes of why you have this problem affecting your why. Say for example, we're talking about the lead time of the delivery of your parcel or your order. You try to list down why is that I have like experiencing some delays or delays. So not all of this, let's say for example, you listed 10, not all of the 10 items affecting your lead time of delivery is it's gonna be like significant. So you have to understand that hey, we have to filter, we have to understand, we have to determine which among these 10 are factors that would really contribute to my why in improving the lead time of the delivery of my parcel, so that I can focus our resources, we can focus our resources, we can focus and our energy to these factors. And that is called the leverage principle, or coming from the Pareto principle, okay, which states that 80% of my problem is accounted to 20% of my causes. So say for example, if like 10 causes, 10 factors affecting why lead time is delayed or whatnot. So you just have to rule of thumb 20% of that 10 is 2 or 3. So you just focus your energy there, and your problem with lead time, 80% of your problem with lead time will be solved. So that's pretty much how Lean Six Sigma works. Now, of course, there's going to be a structure, but this one is, this is the overarching concept. Okay. So let's try to apply it. So late deliveries of order versus promise date. It could be what? Due to an order that was assembled late, or the delivery vehicle problems, or maybe an accident, or maybe during the pandemic, right? personal forget the travel pass or vaccination card. That's why he or she cannot enter that particular facility or area. Delivery rider is not available readily, and maybe the order was overlooked at the store. Okay, so there could be like so many reasons. That's why we need to list them down, try to figure them out, and then from there we need to trim them down, filter, and discover which are really significant to my problem. So that's pretty much how it works. But of course, there's going to be a lot of tools and techniques that we'll have to use. Okay, now what are the benefits of Lean Six Sigma? Okay, so in Six Sigma, um Six Sigma is pretty much called a measure also. So when we say Sigma level, okay, in the context of Lean Six Sigma, the higher the Sigma level gets, the more optimized you are using your resources. All right. So let me repeat that. The more the Sigma level gets, the higher it gets, what happens? The more optimized the resources are being used. So for example, if you would like to take a coffee, if you're at 3 sigma level process, and this is where most of the processes are operating, you need to go to a coast to coast plane ride just for a cup of coffee. Say for example, if you're at Manila, you would want to take some coffee, you will need to fly to Cebu or Bohol or Palawan. Okay, and then you realize it's not actually a practical way of consuming coffee. So let's try to improve. You improve 1 sigma level, it becomes 4 sigma. What happens? You just need to have a 45 minutes drive for a cup of coffee. Say you're at Manila, okay? If you're at Manila, you'll just have to, let's say, go to Tagaytay, something like that. Okay? And then you thought of it that, hey, it's not really a practical way of doing things. So you improve another level, it becomes a 5 minute drive to for a cup of coffee, maybe the nearest coffee shop in your area. And then you realize that, okay, so the ultimate or the optimal way is to be at a Six Sigma level process wherein you're just maybe in your pantry or at your kitchen doing your own coffee. So just imagine. Okay, just imagine the cost of or the resources consumed when you're operating at a 3 sigma level process compared to a 6 sigma level process. And that is why it's important for us to learn this particular approach or structure. So you might be wondering, is 99% process okay? Because Lean Six Sigma, it equates to a very tight I would say customer requirements compliance. So it's like at 99.9999967%. So that 0.9999967%, does it matter? Now, I have here an example of what it looks like to be at 99%. It could translate into 20,000 lost articles of mail per hour, 15 minutes unsafe drinking water, 5,000 incorrect surgeries per week, and 7 hours without electricity per month. So just imagine how we are exposed to risk if we will not continuously strive to become or to be at the Six Sigma level process. Okay? So who benefits? Okay, of course, every organizations and the customer of the organizations that uses Lean Six Sigma will benefit. Organizations will have increased profits because the inefficiencies, okay, the irregularities, the mistakes, the errors will be addressed. Of course, we will experience organizations will experience the reduced cost of them operating, and then increase in efficiencies. This methodology is highly tied up with key performance indices or measures in an organization that reflects how well they are operating. So whenever we subject our process to Lean Six Sigma application, there definitely this process KPIs, this organizational KPIs will be improved. And not only that, because this is a team approach, we are looking forward also to improving the team dynamics of the project team that will be taking on the Lean Six Sigma project for your process and for your organization. Now, you might be thinking, why white belt? Okay, it's because we have like different levels. We call it belts. Now you don't see white belt. White belt is the fundamental belt. It is actually below the yellow belt. And this, by the way, is adopted from the Karate Do and Taekwondo belt level or convention system. Okay. So the white belt talks about the awareness level. So that is why after this and after directing you to the next phase of this, you'll have the chance to get your white belt certification with no cost at all. Okay. Some organizations will ask you to pay for it for about maybe 2,000 or 3,000 pesos. Okay. So next would be the yellow belt. The yellow belt is something that these are persons or practitioners of Lean Six Sigma that applies basic 7 QC tools or basic 7 quality control tools. And in the green belt, they are more they are more adept with the tools and techniques. They can complete actual projects. They basically are they are the leaders of the projects, and they are being assisted by the yellow belts. And then the black belt are the technical experts. They actually teach the green belts and yellow belt. They also take on projects, and they cover a much wider scope of project applications. And then master black belt, okay? We as master black belt, we are enterprise experts. So meaning we try to weave the Lean Six Sigma methodology to the strategic objectives of the organization. So, for example, if we have like a project in the organization, in the company, say we want to improve the efficiency of this process, we want to improve the yield of this process, we want to improve attendance rates, so on and so forth, lead time. So, what happens is that we will try to create a deployment system or a strategy how we can cover all of these things using the Lean Six Sigma methodology. So these are the belt level. So white belt, yellow, green, black, and master black belt. Okay. So when you try to learn more about Lean Six Sigma, there are so many benefits. There are so many benefits, and some of the benefits are here. I mean, in a professional level, these are like, for example, if you're not really into numbers, this will help you become that guy who have the head for figures. You'll be learning how to use statistical tools and techniques. So later on, I'll show you some of the graphical tools and maybe a little bit of the statistical tools that we can learn or we can apply when we are practicing Lean Six Sigma. We will also we will also be improving on our eye for details, because we will be doing like root cause analysis. We'll try to figure out what really is the reason why we have this kind of problems inside our organization. We also have, or we can also improve our reach, our influence, since when you take on Lean Six Sigma projects, you're gonna lead teams, and you will be the representative of the team communicating with other stakeholders outside the project, so your influence will definitely improve. You will of course develop this walk the talk, meaning because you'll earn like the belts, white, yellow, green, black, and master black. Okay. um what will happen is that okay what will happen is that you have to deliver really the results. Okay, you have to deliver really the results. Okay, what else? So on top of that, shouldering responsibility. Lean Six Sigma is a form of project management. Okay, it's a form of project management. So when you say project management, you have to complete it from the start, from the define phase up until the control phase. Okay. Emotional intelligence, we're talking about managing your dynamic team. So it's not an individual effort, it's a team effort. So you have to deal with your your team members. You have to make sure that they are onboarded of what is happening in your project, and it will take your team dynamic skill set for you to be successful on that. What else? Last but not the least, you'll have a solid footing. You'll have a solid footing on how to solve problems, on how to improve process using again the structure. Okay. Now we're talking about the structure. We're talking about the structure, and this structure is called DMAIC. Some may read it as DMAIC. Okay. So the DMAIC approach, okay, it is define, measure, Analyze, improve, and control. So that is what this particular acronym stands for. Define, measure, analyze, improve, and control. So what happens from each phase to the next phase? Okay, so we start, of course, with the define phase. What happens in the define phase? In the define phase, okay, we try to define the right gap. Okay, if you're here, you're a student, you might be wondering, well, what is the gap? Why do we need to define the right gap? If you're here as a professional, you might know the answer already. We have a lot of gaps, and these gaps are manifested through um, problems and opportunities. So when you start working for the corporate, for your companies, for these organizations, then there's a long list of gaps that you have to fill in, and you have to determine which is the right gap that we can focus our energy and resource into. That's the objective of the define phase. Once we were able to define that gap, the right gap, next would be measure the right current performance. What do we mean by that? So of course we're gonna get the performance of this particular process, how the lead time of delivery from order taking to the order serving is this happening, how is our plant's efficiency going on, how is the output coming from our production process is working, how is the turnaround time of our service, etc., etc. So we need to understand that there could be like some errors in the data that we're trying to collect. So we need to understand whether we have the reliable data with us, and really to figure out, pinpoint whether this performance that we were able to measure or that we were able to calculate from the define phase, is it really the performance that we should be looking at. That happens in measure phase. So after that, we were able to secure that, hey, the data is good, it's good to go. We go to analyze phase. What happens in analyze phase? In analyze phase, pretty much we're trying to figure out which among the factors that I was able to generate. If we could go back to the example of the late delivery, and there's like 5 or 6 factors affecting the late delivery, which among them are the right root causes? Not all root causes are valid. Not all root causes will really lead you to solving the problem or the gap or the opportunity that you were able to identify and define, right? But the role of the analyze phase is to really try to understand which among these factors really contribute significantly to the problem. And that is through a lot of analysis. I mean, we're gonna talk about graphical and statistical analysis maybe in the latter part of this particular session. And of course, we have, after determining the right root causes, now it's the time to for us to put the improvements. Okay? So we need to improve the right solutions, using the right solutions. Okay? There could be a lot of solutions that is out there. So we need to identify which one will fit based on our resources that are available. And after which, control phase, this talks about how can we sustain. So we were able to improve this particular process because we were able to identify the factors affecting the performance of this particular process. Say for example, your output per day, your plant's efficiency, your turnaround time for your process, your SLAs, and all that. So the control phase talks about how can we sustain the gain. It is not important really. I mean, it's not the end of the project, or this particular Lean Six Sigma DMAIC approach journey, that when you try to move your current performance to that target performance, it's not really the end, it's just a start. What more challenging is the process of trying to sustain and maintain the improvements that we were able to put into these processes. So pretty much this is what is happening when we try to start a Lean Six Sigma project. We follow the approach. Okay. So it may sound very simple, but you know, there are a lot of tools and techniques. Okay. So these are some. Okay. So let me show you another view. So it's like a toolbox. Okay. Okay, if you're here, you might be familiar with the toolbox. So like the toolbox that you have at your households. So like for this phase, we have this set of tools and techniques. For this next phase, we have this, and then the next one, the next one, and then the next one. So pretty much these are some of the tools that are being used. Okay, when we talk about Lean Six Sigma. So it has this structured approach, and there are like tools, techniques that we can use so that we can arrive to the objective, or we could arrive to the goal that we have set when we started the particular project using the Six Sigma or Lean Six Sigma approach. All right. Okay. So I'm gonna be talking about certain applications. Okay, so these are some of the companies, of course, that uses Lean Six Sigma. You might be part of some of these companies if you're already working. If you're not yet working, maybe one of the brand here or company here is your dream company. So they are using Lean Six Sigma. So it is applicable for both manufacturing and service. Okay. Here are some of the examples. We're talking about material consumption reduction, optimizing the yield of processes, eliminating errors and defects in processes. What else? We're talking about reduction of forecast. We're talking about increasing the compliance of output and decreasing inconsistencies in business processes. These are all driven by measurements or metrics or KPIs, by the way. Services, we're talking about lead time for deliveries of ordered products. We're talking about optimizing contact centers line efficiency, increasing service level availability or service level agreements. We're talking about reduction of errors, maximizing performance capabilities for rendering services. So the possibilities and applications are pretty much applicable to everything for as long as there are ways, for as long as there are ways and variation. Now, for you to better appreciate it, I'll be shifting to another view very quickly. So I'm gonna share with you um, a use case. Okay, and this time we will be using TUOS. Okay, again, TUOS is the first Filipino cloud-based data analytics platform. You can actually go to alpha2os.com and you can get your 90-day trial for this particular platform, data analytics platform. So it will revert back to 30 days, I think, very soon. So you might want to get that 90-day trial by going to alpha2os.com and just creating your account. And you might want to use it for your research if you're a student or for your company projects at your office. Okay, soon enough it will be reverting to 30 days, and eventually it will be on a there's going to be a subscription for every users. Okay, so let's try to put the basic things that we've learned so far in this particular use case or case study. So I have here Felix Burger is a typical snack bar which operates at Batangas. Recently, the shop is facing a challenge about not meeting their target lead time of serving their famous delicious burger of 15 minutes. The lead time starts from order taking until order serving. The staffing model of the shop has one cashier, one chef, one waiter, and a guard. The number of staff, equipment, and raw materials has been found sufficient. Based on initial data analysis, the volume of customers has been stable because there is a need for the lead time to improve as to retain its customers and to even grow. A problem-solving effort has been started using the Lean Six Sigma DMAIC approach. So, okay. So what will we do first? First, we need to collect data. Okay, so the data should be the performance of the process that is involved in this particular case. So that is from order taking to order serving. So we've collected that data for the last 12 weeks. So when we do, we call it baselining. So we collect the data, okay, and then we try to um, look into how the data performs over time or how the process performs over time. Okay. Now, if we are about to use 2OS, okay, so this is 2OS. We just have to use, let's say, a time series. Okay. And then x-axis would be our weeks. So that's going to be column B. And our lead time, our y-axis goes to lead time, or our lead time goes to y-axis rather. So that's going to be column C, and then we need to run the function. Okay. Why do we need to do the baselining? Because we want to understand better why are we having this problem or how the process performs over time. Okay. So let me try to. So that's gonna be B and C. Okay, we need this because we need to write what is called a project charter. Okay, so the project charter is something like this. So try to increase. Okay, so it contains the business case. It contains what is really the problem, what is the objective, what is the scope, how the process is performing over time. So you can see this is gonna be the output of TUOS when you do the time series. What is the project timeline? What are factors that that we need to consider that when we improve the lead time of order serving and order taking for the burger, this factor, the consequential metric might be affected negatively. So we do that as form of risk assessment. Then we have the team that is assigned and the top management. So pretty much, okay, so I think I need to reset my anyways. So that is the first step. You need to create the project charter. So that contains the all the necessary information about your project. So like for example, the problem statement: higher average lead time of serving Kalicious Burger from order taking to order serving at 18.29 minutes versus the target of 15 minutes, which is a gap of 3.29 minutes since July to September 2021. Okay. So from there, we were able to define the right gap. Okay. Hey, this is the problem. So at the same phase, during the define phase, we need to create a scoping tool. What is meant by a scoping tool? Sorry, I'll just try to. Okay. B and C. So, what is a CPOC diagram? So, CPOC diagram or suppliers, inputs, process, output, or customers. This give you a view, really, of what are the process steps that are involved in the process that we are trying to improve or trying to solve a problem with. So, if you can see here, these are high-level process steps. So, for example, if we use this particular use case, we need to cover the order taking and then the order serving. Okay, so we put that. So and if we look into that, okay, so we start with order taking, the take order until the serve the order process step, and this will be the coverage and anything that is in between or within this particular scope. Now, when we go to the next phase, now we have defined the right gap. Now we try to what? Measure the right current performance. But before we can do that, we need to first understand how the process works. How do we do this? We create a detailed deployment process map. So what is a detailed deployment process map? So it's a process map that shows us the details of the process. Well, we refer to what? We refer to the CPOC diagram process steps. And then we try to break them down, the steps, the higher level steps, we try to break them down into smaller details. So just like what I'm trying to present here. So when we try to do that, we need to also consider and to subscribe to several sources like the process expertise of the subject matter expert, the experience of the users of the process, historical data, okay, and your observation through what we call the Gemba walks. Gemba means actual workplace. In English, it's a Japanese term. So it's when you go to the actual workplace and observe what is really happening. So coming from those sources, you'll try to come up with what we call the potential causal steps. So what is the potential causal steps? These are steps that could potentially cause the problem of longer lead time in serving Calicious burger. Okay, so that is the measure phase. Okay, now next would be, of course, the root cause analysis. So we were able to identify now what is uh what are the potential causal steps, okay, affecting the lead time. Okay, so now we try to generate the potential root causes. Okay, this is called a YY analysis. So what I do is I put here on top of the YY analysis the problem statement, the entire problem statement. Okay? So YY analysis works in such a way that you have to ask series of why. So the answer to the first question why will be the reference on asking the next set of why, and so on and so forth. So for example, so why do we have a higher average lead time observing Calicious Burger, blah 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 blah. So it's because of the process step prepare ingredients. So if you can remember, we have chosen potential causal steps from the measure phase. Now these are inputs to my analyze phase. I will now be focused on this two or three or four process steps out of like 12 or 15 process steps. I will not think um non-directionally, thinking that hey, I could like pop up some any other whatsoever root cause from any other step. So it's gonna not gonna work that way. So we need to have that direction. We need to have that structure. So why do we have like a higher lead time? So the answer is because of that. To say you choose first, you choose out of the two or three that you've chosen as potential causal steps. We focus our energy there first. And then after that, remember this, that for every process step, there could be like 5 to 6 elements. We call it the 5M1E. So what does the 5M1E stands for? So it's man, or it's machine, material, method, measurement, man, and environment. Okay? So why do we have this? Because of prepare ingredients. Why? Because prepare ingredients, now you break them down or break it down the step into the 5M1Es. So that's third why. So for example, because of machine relative to the prepare ingredients. So why machine? Machine is always down. Okay, before I forgot, when you try to generate a list of potential root causes where you're using probably YY or fishbone, make sure that the potential root causes are always stated in a negative tone. So for example, machine is always down. So you don't want to put there like under machine breakdown. So what's something unique with machine breakdown? You could say like frequent machine breakdown, something like that. Okay. So this one, machine is always down. Then you ask again, why is the machine always down? You could say like machine is not being maintained properly. Why is the machine not being maintained properly? You can say that no one is checking the maintenance schedule and execution. Okay. So the reason why I have put that particular um, answer in bold is because this, this I would say branches. Okay, the farthest one, okay, would be the items that we will be considered for validation. So we will be considering that for validation. All right. So all of the answers that is in the farthest position from my original problem statement. So we could, so after doing every, let's say for example, for this prepare ingredients for machine, so it's not, if you're using like two machines or so, then you could have like more entries to this. So after machine, you move to the next, and then you move to the next, and then you move to the next until such time that you've exhausted everything, and then you just go back to the next process step. So when you're done with this step, you go to the next one. Okay. So what happens next? Okay, you now have a long list. Okay. So if you have like three selected potential causal steps and you have like a potential of six, okay, six potential root causes, that's going to be 18, right? 3 times 6, it's 18 potential root causes. Now, you might not have, of course, the energy, the resources to prioritize everything. So that is why you need to, or you sorry, you don't have enough energy to take everything, to cover for everything. That is why you need to what? You need to prioritize. And that is where the Pareto principle will come into the picture. So what does the Pareto principle talks about? It talks about what are the 20% among this list that really contributes to my problem, my lead time problem. Okay? So that's pretty much the objective. And the 20% will reveal that 80% of the problem will be solved when I focus on this 20%. That's why it's called 80-20 rule. Okay? So for example, when you listed all the potential root causes, you gather the data of how frequent they surface or they become a source of your lead time problem. So you can use, for example, platforms like TUOS. Let's say you go to your graph and then you use a Pareto chart. It says here, where are the categories? So your categories is at E, and you're gonna be using E and F. So Pareto chart, E for categories and frequencies. Let's try F here. So it will give us a Pareto chart of, okay, I think I'm having trouble with my net right now. All right, so there you go. So this is now your Pareto chart. How do you use the Pareto chart? Very quickly, if you want to learn more, you could reach to me via offline. Okay, but just very quickly. So you see here the secondary axis, right? So this talks about the cumulative impact of the individual root causes here, or factors here. So when we trace it, you just look into the 80% in the secondary axis. Try to um like draw an imaginary line towards this red line here, which is called the cumulative percentage line. So once it intersects with this one, okay, or once it meets this line here, then you just have to draw a line that goes down here. So it only says that from this particular potential root cause number 5 all the way to 4, 11, 6, 3, and 1, these are all called the vital few factors. What do we mean by that? These are the 20%, or roughly rule of thumb, 20% of the factors that is affecting my lead time. So I have to focus my energy on them, or I have to focus validating whether they are really the factors that we are looking for, so that we can make an impact to our problem. Okay. So once we do the prioritization in the premise that we have so many factors that we need to look into. Okay. So that's basically the logic to that. Okay. Now, once we were able to prioritize, okay, we need to what? Analyze. Okay? We need to analyze. Okay? When you're trying to analyze, what are we trying to analyze? We are trying to analyze the relationship. We are trying to relate to analyze the relationship of y and x. Remember, your y is your lead time. Okay? Your y is your lead time, and your x's are the potential root causes. So we're talking about say for example, the availability of the ingredients, or probably the number of errors committed while preparing for the burger, or probably the level of inventory of the ingredients, or the skill level of whoever prepares the burger. So these are factors affecting my why. So in the context of analyze phase, what we're trying to figure out is which among these factors really is significant to lead time as our why. Okay. Now, um, what you might want to do is to, of course, get the data. Okay, so if you can see here, so we'll be using it later. So for example, this data here is lead time data. This columns here, it only says that, okay, lead time is longer if materials are not yet prepared beforehand, or lead time is affected by um the level of preparedness of ingredients, namely when ingredients are prepared beforehand and and when rather the ingredients is not prepared yet beforehand, something like that. So you're trying to compare, okay? So if we use TUOS, we can use, because we're trying to compare if whether there's an impact of this lead time being ingredients are prepared or not prepared. We can actually use a box plot. Okay, so a box plot is a graphical analysis tool that we use to compare the distribution of certain data sets. So for this case, these two data sets, H and I. So we can go to graph, go to histogram, and create a multiple variable histogram. Oh, sorry. Can we try histogram? Ah, sorry. Box plot rather, box plot. Okay. Variable one, let's plot the lead time for when the data or for when the ingredients are prepared beforehand. So that's H, and compare it with when the lead time. What is the lead time when the ingredients are not yet prepared? That's letter I. So we click run function, and we okay. So we will have this kind of view. So apologies for that. Internet is a little bit challenging. So, prepared ingredients, this is what the lead time looks like. Okay, so if like 15, if this is 15 somewhere here, so we can see that hey, when the ingredients are prepared beforehand, what happens? Okay, that the lead time is what shorter. It's within the target. But if the ingredients is not yet prepared beforehand, it is way too high. The lead time is way too high. So with that kind of result that we had from the data analysis, we can now conclude that hey, with that we can say that the factor that we're looking at, preparedness of the ingredients, is really like a factor that affects lead time, because we see that there's really a difference in terms of this two box plots here. Okay, now if you're like a little bit geeky, so we can actually try like some basic statistics. Let's say two sample t-test, which actually compares the average of two data sets. Okay, so that's I and H. Of course, this will gonna fall under advanced hypothesis testing. So then you can have this. What's good about 2OS is that if you know already how to read p-values, confidence intervals, we're talking about basic statistics, right? So we have here like a column or a note here. Since p-value of column H and I is less than the alpha of 0.05, therefore reject null hypothesis. It's going to be a little bit alien for some, but hey, this is the practical one. There is a significant difference. So when you read this, meaning the different levels, or the two levels of the factor that you're trying to compare, is resulting to different levels of lead time. Therefore, they the factor is a significant factor, because if it's not a significant factor, then the levels of performance from being the ingredients being prepared or not prepared should be just the same. That's the logic to that. Okay, so that's pretty much how we do that. And of course, we can also like do some time series using 2OS. We can do like some scatter plot. So these are tools and techniques that we are using. What I'm trying to point out here is it's gonna be like a very data driven approach. Okay, first level it will be graphical. Second, it will be statistical. Okay, or data driven really. So once we were able to validate, okay, we were able to validate. Okay, then we need to what? We need to assess. Okay? We need to assess. Okay? We have like matrix that we can use. So we have like the peak matrix or impact effort matrix. We try to assess whether hey we need solutions. We're now in the improve phase, okay, because we were able to validate the root causes. If the solutions have low requirement for effort but has high impact, then we prioritize it. But if we have like solutions that has high effort requirements but will gain high impact as well, high benefits, we need to park them for further investigation because it's something that requires high effort. Could be like investment in terms of money and all. So if we have like low effort, low impact items or action items, we consider that. We call them the quick wins. If we have like high effort solutions but low impact, we kill that idea. So this is like a simple way on how you can prioritize your solutions. And then of course you have to put them in an implementation plan, okay? So that whenever you started deploying the solutions, you have like a tool or a table that you can refer to of what is the valid root cause, what are the recommended actions, who is the person in charge, what is the target implementation date, and what is the current status of that particular solution. So after of course having that solution, then you might want to have like a comparison whether you really have some improvements or not. So again, you can just pretty much use probably a yeah, another box plot will do. Okay, so comparing the before q and after. So if we will try to compare, we're pretty much expecting that the before is higher and then it's going to be a lower this time. We're talking about still lead time of you serving you order taking to order serving of the Calicious burger. So if you are seeing this or if you've seen this particular movement in your lead time, then it's a good indication that the items, the improvements that you were able to put into your process of order taking to order serving of that burger is really paying off, is really working. Okay. And then last but not the least is you have to prepare in your control phase things like what are the items, what are the actions that I need to put so that I can ensure that all the things that we were able to deploy as improvements will stay. And that is why we have a pros control plan. So for example, if you say that you'll be doing advanced preparation of materials plus standard level of ingredients inventory for the day, that's an input. Why? Because it's an X. Y is a function of X. Only lead time is your output here. Okay? You go back to this one. So 1 day level of ingredients. So that's the requirement. It should be like 1 day level of ingredients in the kitchen at any given time. So what is the control method? It could be audit. So what do we mean by control method? It is something like, hey, how can I ensure that the level of ingredients is always at 1 day level at least? So we do audits. So control method answers the question: how can we ensure, what are the mechanisms that we can use or we can deploy that would make sure that would sustain the improvements that we were able to deploy. Okay. What is the frequency of executing the control method, and who is the person responsible? So that's pretty much a simplified walkthrough of how Lean Six Sigma DMAIC works using TUOS, of course. There's a lot of other stuff that you can play around with TUOS. So all you have to do is, all you have to do is to download your 90-day trial here at alphatuos.com. Anyways, so pretty much I would like to share with you it again. So these are the phases. Okay, these are the objectives for each phases. These are some tools. Okay, these are some tools that we can use. And if you want to learn more about this, you can, you know, simply send me a message, um, and let's talk things over. I guess that's gonna be. I'm sorry, I still have some more slides, but very quickly, just want to share what are some projects that I did so that you'll have an idea very quickly. So for example, in my last 10 years, I was able to apply Lean Six Sigma in optimizing the number of machines that are being used in a manufacturing facility. Supposedly, like they have like 100, they used to use every one of them. but we were able to reduce the usage with the same output to like 80 or 70. Okay, so we're also using Lean Six Sigma in our business here at Aslex when we want to optimize our product mix and our pricing strategies. So some technical things like when you do when you're in manufacturing or service, you need to like get number of samples from a process to make sure that your process is performing within the customer requirements. Lean Six Sigma could be used to optimize and set those, sample size. So we were able to also use Lean Six Sigma to look at this chart here to reduce or to eliminate customer complaints. Okay. Yeah, stuff like reliability engineering, you could use Lean Six Sigma as well on this kind of projects. Logistics, if you're in logistics, I've used Lean Six Sigma in optimizing our warehouse. I used to work for this leading beer manufacturer here in the Philippines. We've used Lean Six Sigma to reduce the overall supply chain costs by through reconfiguration of supply chain networks, transportation allocations, and distribution management. In business, you could use Lean Six Sigma to um, determine the optimal location for your business or for your next branch of your business. So we have like also projects that um, addresses life cycle improvement or optimization of materials used for production. Usually, this material, an adhesive material, it is being used for 11 cycles, but we were able to improve that up until 21 cycles. So just imagine half of it becomes a saving, and that translates to thousands of US dollars, hundreds of thousands of US dollars. So this one, another manufacturing related project on tray optimization, and I guess that's gonna be all. I mean, learning Lean Six Sigma, this is like a very quick masterclass, probably really an overview for white belt level, but it's really gonna give you an advantage. For me, it works for the corporate up until when I wrote my paper for my masters. It's still the topic since the structure is really there and it's working. So I guess that's gonna be all for my end, and I'm now open to any questions that you might have. Thank you.
Meron din akong question kanina while listening to the discussion. Ano po? When you were actually giving these samples that you used Lean Six Sigma on your own part po as for example sa manufacturing and sa mga current destination or location ng mga business. Pero personally po ba, personal experience where your team or ikaw po mismo really benefit from Lean Six Sigma? And paano po kaya yun nangyari? Kasi we have different scenarios kanina like sa kitchen, sa production, and stuff like that. Pero personal experience po ba, meron po bang in which you have applied Lean Six Sigma?
Sorry, ano yung ibig sabihin ng personal experience? Like personal life ba yan? Or
Ay, like
in
for
our
example, sir, in your current job po or in your current industry that you are in po. Like for example, ask Lex,
Mm.
may iba pa po bang a scenario in which you've used and benefited from Lean Six Sigma?
Well, currently kasi our engagement is more of training and consulting. So
Mm-hmm.
we've been exposed to many applications from BPO to manufacturing. For our team, we're trying to use the approach kasi ang ano natin dito for Lean Six Sigma is that hindi not all organizations are ready for Lean Six Sigma implementation. Someone is asking about why do Six Sigma projects fail? It's pretty much for large organizations, I would say it's really the buy-in. It's really the management support, because it's really hard to implement something that is structured, but if you don't have like the support for the resources that you will be needing, it will always fail. And this is like, this holds true not only for not only for Lean Six Sigma, but for anything that is being implemented. So you really need that support. Okay? Because the structure is there. It can be enabled by a proper support system. So to your question, yeah, we're trying to apply Lean Six Sigma. We have like interns that are helping us since we inside the organization cannot really sit down and apply this. But I'm positive for MSMEs. This is something that they could really explore. And we are, if you're here, you're an MSME, or some MSME, we're actually deploying people to MSME to help them improve their processes, their business using Lean Six Sigma for free, because we want to prove that Lean Six Sigma works not only for big organizations, but for micro and small businesses as well.
And sir, actually, we have another question here from Ma'am Jella. Should we be with a company or in employment to be a Six Sigma? Yung
Hmm?
question niya po.
Okay, so maybe the question is whether they have to be employed to
Mm-hmm.
learn Lean
Yes
Six
po.
Sigma. Initially, well, for our classes, not trying to promote anything or what, but we train students as early students, yellow belt level, or on that level, because we don't need to apply for a project. Unlike for green belt, you need a company because you need an actual project. But for white belt, yellow belt, you don't need to be employed. um our success story, we boast the success story of our students being employed to these companies because they've acquired the certifications prior to graduating from college. So yun yung that's what's happening.
Mm-hmm. And Sir Felix, could TUOS tools be also used for DMADV approach? And sir.
Okay, yan. So yung, yeah, TUOS, oy, thank you. May promotion ng ng slide. So TUOS kasi is yun nga, our baby. It's as like
Mm.
Speech Academy's baby. There's a pain point kasi, no, if you're not a person who uses R or Python, because you can do data analysis using R and Python, but not all person are persons that will learn coding or
Code.
programming.
Yes.
So, but when you try to buy kasi, it's really costly. It would take, for example, you're an individual, you would want to, I don't want to mention na lang mga softwares. It would be around 70 to 80,000 per year per person. So just imagine, if you're an MSME, how can you even avail that? 'Di ba? So that's the pain point. That's why we created TUOS. Okay? So TUOS right now po, it's in the development. I mean, we soft launch, but we're now on the phase 2 of the developments. Yes, to answer the question, it's a yes. You can use it for define, measure, analyze. We're trying to build also design of experiment modules inside TUOS, that you can use for the MADV approaches. So yun, and even control charts. So the answer is yes. Eventually, in by this year, hopefully, activated na po yung functions that would allow for it to be used in the MADV. The MADV, by the way, for those who are not familiar, it's another approach under Lean Six Sigma. So it's being used for whenever you are trying to create new products, process, or service. Unlike DMAIC, it's improvement, meaning nandyan na. It's already existing. The process is already existing, the product is already existing, and the service is already existing.